Hello everybody, fellow gamers, welcome to a Mixed Stardust Redstone tutorial. This is quite different from anything that I've done previously, but I was requested to make a tutorial by one of my viewers, and I don't want to let them down, so I've decided to go ahead and put this little quick comprehensive view of some of the things that I know about functionality of Redstone together. As you can see by this quick flyby, it's nothing really too complicated, but I know a few tricks. I know a few more other things to do than this, but I just kind of threw this together real fast to get some basic principles out of the way and see if maybe people would like to see some more of what I know of Redstone in the future. So, beginning from the very basic principle of Redstone is essentially that Redstone is equivalent to the electricity or power in Minecraft, which is probably the most well-known fact. Anyway, just to have a total comprehensive basic beginning look of Redstone, you can think of a single torch as a kind of like a power generator or an alternator or something like that, which would generate an electrical current. Okay, now this next area over here I've got set up is just to signify the fact that this single node will transmit, unless told otherwise, to transmit its signal in 4 directions. Okay, that's important to understand when you're running wires close together or you're running wires that are touching walls and things like that. The next thing that everybody should know is the fact that the signal decays over a certain amount of blocks. As you can see, this block is 16 spaces away, whereas this block, which is not powered, is 17 spaces away. Now you can see here that the particles are emitting from on top of the redstone wire, and it's not animated over here. This is really dark, and this is not getting any power to it, whereas this one block closer is. Okay, we can see from the split here, this has a distance of 1 space, and then it goes to the block. Over here we have a distance of 2 spaces, and then to the blocks. This is just a difference of 1 space. So looking back over here at our torch, we can see roughly the total distance that the redstone will travel. Now this little setup here is just to showcase the fact that instead of using a torch every time, there are alternative options for configuring your redstone devices with a power source. So basically, the lever here acts as a power generating unit itself. Okay, now this lever will charge the block that it's on and provide power to the connected contraption. Alright, I use these a lot for doors. You can make combination locks and all different kinds of neat little things with levers. Alright, and this setup is pretty much the exact same theory as that. It's just it turns this on and it powers the light. The only difference is in this display I just have the wire here to show that this in fact will generate a signal that will be transmitted from the switch without having to have a torch. Alright, now this one is just slightly different than this one in the fact that this is an inverted signal or a NOT gate setup. Okay, this is a very basic electrical engineering type of logical gate. Okay, as you can see that this one is on when the switch is down and it's off when the switch is up, whereas this one is the opposite. This is on when the switch is up and off when the switch is down. And the way that works is because the torch by default is always on. So when it receives a signal from your network or your circuit, it will shut the signal off. Okay, so it inverts the operation function of the redstone torch, and that will shut our light off when this one is down. So if you want to just kind of have a light switch where it functions like they do in real life, where your lights are off and they're on, then this simple NOT gate is an easy way to go about performing that operation. You can come up with many more uses for NOT gates, and I'll show you maybe one or two more of those in my tutorial. I'm not quite sure what I've got. Okay, over here onto this one, I'm just kind of showing the idea how over here, when I was explaining that the signal will be transmitted to every square from the source of the pulse, and then over here where I was explaining how a switch will create this block as the source of your signal. Now, this just is kind of an example to confirm that idea that no matter how you have a machine connected to a block which is receiving a signal transmission, that it will charge that block. So if you have your circuits all really close together, you've got to be careful about how you have your machines set up if you want them to function the way you intend, because otherwise you're going to have things that you would think are unconnected when you've made a simple layout mistake. Now you can see here, however, that because this block is not attached or immediately adjacent to the source of the signal, it's not transmitting power to this block. Okay, and on to the next step. Here, this is another simple example of how you can easily grow your circuits vertically rather than horizontally or laterally. Or horizontally and laterally, I'm not sure. So anyway, what's going to happen here is we turn this signal on, and this torch is going to in turn charge the block above it, giving power to anything that you would want to connect to this block. That could be redstone on top, or a device or something to that nature to the side. Okay, so there we go. Without having to run a line of redstone coming around and coming back up to it, we can be much more resource efficient just simply by adding a torch below a block. If you guys would like to see more of how you can stack torches to create chains of vertical networks, I'll put together a tutorial explicitly for those ideas. Okay, now this one is a simple dungeon type setup where let's say that this switch was somewhere way over there in our little dungeon maze. Okay, so now we have the pink switch, which is going to be in the pink section, and this basically just turns on a light. Over here I have the same exact setup as behind the wall, so I can show you without having to run around and go back and forth. We can view the entire picture here at one time. So now you can see over here I've got a very simple setup where the switch is on the block that's in front of the piston. Now on top of the piston is a lamp. So when we flip the switch, it raises the lamp up, and that connects the circuit to the lamp from the redstone torch and provides power, and thus illuminating our pink lamp. Okay, now you can see if you had a setup where, say, we had like a pink, a purple, a blue, and a green switch or something like that, and we had some type of a combination lock or an event that we wanted to have transpire, that these are a nice organized way of being able to create puzzles that are comprehensible to the people who are going to be experiencing your build. Now, back on to another idea. Right here we have a simple AND gate. Okay, the way this works is by creating a network of two torches which are connected by one wire. Okay, now this is charging this block right here below, and is inverting the signal of this torch. Now that turns the lamp off because it's not receiving any power, even though these switches are on. Now, the reason why it's called an AND is because, as you see, whenever I select just one of them, this one is also still powering it, and it's continuing to have this line here be inverted. So now when I hit this one and this one, it will turn the light on. So that's a very simple operation you can use for coming up with combination locks and stuff like that. Use your imagination, you know, I mean, you can do a lot with Redstone. I've seen people making computers and using things like this, which is the next step in our tutorial. This one is kind of 3 parts all put in together because of the crazy way I just throw things together, and yeah. Anyway, so what this is a simple OR latch. I haven't really played around with these too much, and I'm not a electrical engineer or anything like that, but the basic idea is that an OR latch creates memory storage within something of a larger logical network, like a computer setup or something to that nature, where you would want to remember signals pulses coming in and out from a device and communicating information across a circuit grid. Now, basically, this simple circuit comes over here. This one is on, so it runs in a circle and turns this one off, and this goes onto a larger loop within our circuit. Now, what's happening over here, I'll get to in a moment, so just forget about that. Just pretend that these are just kind of going in a circle. Now this one will turn this on, or off rather, excuse me. And so as soon as this block stops receiving a charge, this one charges this redstone, which comes over to here and turns this one on. So this is a really simple loop which stores the value of the last signal that was input into it, which is used for much more complicated things when it comes to machining and stuff like that. But as I said, I'm not exactly an electrical engineer, so I don't really know, other than this quick comparator introduction that I came up with. I have to play around with these latches to really get a full scope of what the capability of these are. I just learned how to use these myself. I just wanted to showcase that it's a thing. It's pretty simple to set up, and I come up with one practical application. So what I've done here for this tutorial is that what we're doing is we're using a Redstone comparator, which is another device that I'm pretty unfamiliar with myself. I've actually only messed around with these like twice inside of game because I use more straightforward things for what I typically do. So I'm trying to learn as I go here. Anyway, just wanted to show that it's a thing and explain the basic functionality of it. So here you can see that we are getting a signal from this redstone repeater. Now, if we count the spacing here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then this would not be getting power. Alright, so now the entire purpose of this is to show you how the repeater functions, because even though the spacing is shorter from the source of the signal, this redstone repeater will act as another node to retransmit the signal that it's received from the source. So essentially, if this repeater was all the way down here and we connected it here, we could double our transmission length, but I didn't need it to do that, and I wanted it specifically to measure this distance to show you how it works down here when compared to... Always rains on me. I gotta get the command to toggle that off. I got the animals and I got it at daytime all the time. Just throwing these together. Yeah. So anyway, like I said, this is the maximum range for the redstone signal, and it's going into the comparator here, which is acting both as a repeater and as a simple logical mathematical function here. Because we can toggle this, I'm not quite sure what to do with its default mode at the moment, so I'm going to have to get back to you on that. But when it's toggled here with the right click, you can toggle it, and that will change the state of the function that this is behaving. What this is doing is it's performing a subtraction lithogram, basically. So now I'll show you that that light is on all the way down there, but the further one isn't, even though this isn't at 18 spaces or 16 spaces, because it's subtracting the number from this torch, because it's 1 block away, and I'll show you that in a second. They receive a signal on either side, so the left side, the right side, it doesn't matter. So you can use this to compare which switches are thrown, okay, and based on the switch you're thrown, you can get this to perform a different operation. There are other methods that we can use to measure all sorts of different things and create some contraptions. If you guys are interested, I will put some of those together, and I'll show you all kinds of other things that you could do with redstone, but we're just kind of keeping it basic right now. So I'm going to turn this one on to show you how this works. Okay, now see, what this is doing is it's reading a signal coming from this lamp 1, 2, 3, 4 spaces away. Now it's subtracting or comparing to this number here that is receiving a signal 1 space away. So the function is that it's comparing 4 to 3 and doing a subtraction, and this will generate a signal strength based on the comparison of the numbers with the subtraction method. Alright, another practical use that I could think of for this function alone would just be like something of, well, for one, you could test signal strength and use that to power different machines. Okay, so we'll say that if it's getting a signal strength of 4 here, then it will turn this machine on, or 3 rather, but if it gets a signal strength of 4, it'll turn that one on and this one. Or what we could do is put a circuit breaker in here, so if this one's on, then that one's off, and keep going down the line, but eventually you'll have to start building a larger circuit to use that method. Now maybe there's another way that we can perform the same operation more logically. I'm not really too sure, because I'm only limited with my knowledge as I've basically learned through experimentation. So now what this is doing is it's subtracting 1 from the length of the signal that it's receiving. This is coming out 15 blocks. So this will short out our signal just a little bit more than we saw in our previous example. So we won't get it powered from here. This is a full 16 blocks, or yeah. Anyway, so this one will work and this one won't, and this is the default redstone signal length. Okay, so you can see how it's performing that subtraction operation. So on to the next tutorial, we have a combination lock. Okay, This one's a little bit more complicated, but it's not so complicated. This is the way I figured out how to do it, and I've been thinking about it actually, and I think that we can use NOT gates to kind of do the same thing. I don't know, I haven't messed around with using those in my combinations because I just, from my own experiments, learned that making these circuit breakers with sticky pistons works just fine. Now, what happens is when the repeater gives a signal, and I'll show you here, let me just grab some redstone, that when the repeater gets a signal and puts it in through a block, it will pass it through the block. Whoops, wrong switch. But when it's just the redstone going to the block, this will be interrupted no matter what. That circuit is broken. But the repeater allows you to have your transmission be casted through the block. Okay, so we can use these not only to relay our signals, but to act as part of a network in unison with a circuit breaker, such as I have here. Okay, now the way this works is it's a simple circuit here. We have our operation mode, or our power source, coming into the circuit, but the circuit's broken. So to complete the circuit, we need to make two more connections, and that will turn the light on. Okay, and the reason why I have the torch there is because I wanted to make it a combination. Okay, because now these are all on. You don't know what this function does until you start to experiment with it. Okay, even though you can hear that the circuit breaker is moving, but you're not quite sure what that function is doing. This one's really simple, so it's not too complicated. But you can see, no matter what the state of these switches are in, as long as our combination is wrong, there's nothing that you can do that's going to make this turn the light on. Okay, so now this is an easy example of how you would set up a dungeon dungeon circuit, basically, for challenging players. Okay, so we would just have like different color lights, like I have set up over there in that example. And each one of these lights would be corresponding to a different location within your dungeon. Alright, so our combination is no, no, yes, or 0, 0, 1, something like that, however you want to look at it. Either way, it's a binary function. Okay, now that's enough of that. We're going to come on to our next example, which is my crude clock, which isn't exactly the most efficient method of doing this, but before I knew any better, this is the method I devised to do it. So I just kind of wanted to show you guys that there is more than one way to perform the same thing. It's just a matter of how you decide to get the job done. Now, I don't like to really use this method anymore because it's kind of noisy when the machine's functioning, and it's really not quite efficient. As you can see, it takes up more space, requires more components, and it's noisy. Okay, so what's happening is it's creating a simple breaker circuit by tripping the redstone torch, kind of like the same way that the OR latch over there is doing. And when it comes here, it just inverts the signal and carries on. And the way that this is working is because when the piston is off, it breaks the circuit, and then it charges it and it lets it go through. And I don't know why, personally, I ever found this way to do it. I'm not really a professional, I guess. This is just, I didn't realize that plugging this in just doesn't really do anything. But yeah, so that's a simple clock, which we can use for larger operations, such as this timer. Okay. Now over here we have the proper way to actually build a clock, which I've only just broken the circuit here with the torch missing. So what happens is, again, it travels in a small circuit, comes over here, and it trips itself off. So when it's off, eventually the line completely voids itself of energy, right? It comes into here, onto the repeater, and then it's not getting a signal, so it turns back on, and it continues to go in circles like this. Okay, now here we go. We see how this is functioning as a timer, but let me just show you something real quick about how this is working. Okay, what's happening here is these repeaters are relaying the signals, and they're going each respectively in their own direction. So that way, if you have complicated circuits, the repeaters will stop redstone signals from coming back around on each other and reconnecting. And I'll show you exactly what I'm talking about here. Because as you can see, like if we had some redstone coming over here and running around this way, it's all going the same direction, right? And if we have more lines coming out this way, let me just show you. We can use these repeaters to block the signal from going this way. So we could have multiple modes where our signals are being sent across the same bus, but they can't go in the opposite direction. Okay, see, if I turn this repeater around, you can see that it will extend that signal, but going this way, it acts as a gate or a blocker to prevent feedback from going where you don't want it to. Now, what's happening here is the redstone signal doesn't transmit through glass. So this is acting as an insulator at the moment, okay? And it's preventing this power signal from reaching here. Okay, now as you can see, when the wool travels around on our timer, now you can set these up to a total of 12. Alright, and you could probably come up with a more complicated path for them to follow as well. If you want to make your timer longer, you could use less blocks if you want to make it shorter. But this is the simplest method I could think of to make a timer anyway. So the tricky thing is about the timers, what you want to really watch out for is the length of the path that the redstone is traveling. It doesn't completely travel instantly, and the repeater automatically sets a small delay on the tick. So you have to take in for account how many repeaters it's going through, but it's not too big at first. But as you can see on this one, see this lever's all the way down, whereas all of the rest of them are forward, right? That increases the delay on how long this one takes to function. Now it's not too big of a difference, but as you can see here, this light turns on just before this one moves. Okay, now what that's doing is it's giving this one just enough time to retrieve or retreat before this one activates. So you can see now that they're all functioning in unison. Alright, so you have to be careful when you're setting up timers that you have a delay to allow them to operate properly. So as I was saying, this wool goes around in a circuit, and every time it comes past this point where the power's coming out, it gives our circuit over here power. And what that's going to do is it's going to just invert this node, okay, because it's charging this block and changing the input signal from this node and inverting that. And the reason why we wanted to have it inverted or as a NOT gate is because we have power coming over here to this setup, which is a simple little dungeon obstacle I've created for the example here on this tutorial. Okay, and what this is doing is the door's locked. And what we want to do is basically just create a simple obstacle or a challenge for our players to have to hurdle through. So now you can see that the doors open and then they close briefly, or they open briefly and then they just close again. All right, so let's see if we can make it through here. Let's get the timing going. Okay, see, we've got just enough time to run through that before we get slammed in the door. Now, if I wasn't in creative mode and I failed to go through here, I would take damage, or if it was something like quicksand blocks, I would get stuck in there and start suffocating. Okay, so depending on how treacherous you want to make your pitfalls or your obstacles, you can come up with different things. This setup here is just kind of like this because having them right next to each other is a little bit tricky. I didn't want to run a whole lot more complicated wiring going to this to get it set up. I could have done something like this, but like I was saying before, there's more than one way to do the same thing, so I'm just kind of showing that as well. There's always another solution, usually. So that's about it. Okay, we've got a clock creating a timer that's operating a trap, and we've got this stupid thing I invented, combination. Okay, so that's another obstacle. We've got comparing signal strength. Okay, and we've got an AND gate. We've got a simple light. We've got another way of transmitting energy. We've got many things happening at once. Okay, we've got a NOT gate. We've got a regular circuit. Same thing. Okay, we're showing total redstone distance. We're showing that the signals can go in different directions. Okay. Well, let's just move this one up here. Alright, see, that won't power there. Alright. You get your wires crossed and you start getting into trouble. So the layout of your circuits are very important. So we can connect all of these like this. And we can make them go out any direction we want. Alright. You can come up with all different kinds of things depending on how you set up your circuit. And that's about it. If you guys would like to see more things that I've devised, leave a comment and I'll see what I can do about making another video like this. I hope that everybody's enjoyed what I have to show. It's not too much, but I don't know too much about Redstone. I just kind of toil around with it. I like to build dungeons, you know. I really enjoy creating puzzles for people. So thanks for watching. This is Mick Stardust, and I'll see you next time.